Hi, and welcome to the first video for Module 3. Module 3 is a video on loans and bonds, and what I hope to convince you of is that mathematically they're the same thing. Now, when I think of a bond, I'm thinking of us as being the borrower. So we're borrowing the money, and when we think of bonds, when I think of bonds, I'm thinking of us as being the lender of money. So you'll see that as we progress through the videos. This first video is on loans, though, and we're talking about just loan notation and terminology. So let's get into it. I'll use capital L. This is not just my notation. This is pretty standard notation. I'll use capital L as the loan amount. Again, what I'm saying, I'm going to start using an abbreviation for capital L. It's cap L. So capital letters, and I'm going to just get tired of saying the word capital, so I'll abbreviate it with cap. Cap L is the loan amount. I didn't say cap I. I is the periodic effective loan interest rate. N is going to be the number of periodic payments. And now let's talk about some of the payment amounts. We'll use a cap R sub K as the amount of the kth payment. Cap R sub 1 would be however much the first payment is, the amount of the first payment. Cap R sub 2, the amount of the second payment, and so forth. And now we're going to get into a couple of symbols. We're going to think of that payment as being separated into two parts. First, we're going to look at the amount of interest paid during the kth period. And then we're also going to look at the amount of principal repaid with the kth payment. So when we look at a particular payment, part of that payment is going towards paying interest on the loan. We're being charged interest on the loan. So part of that payment is being used to pay the interest on the loan. The rest of it is used to pay back the amount that we borrowed. So there's this basic, I might as well throw it in, there's this basic relationship between these last three symbols, and that is that the amount of the payment is equal to the amount of interest that we're paying during that period, plus the amount of principal that we're repaying with that particular payment. Okay, so that's a relationship that we'll use quite a bit. Okay, and then finally got one more symbol that I want to throw in, and that is that cap B sub K is going to represent the balance immediately after the kth payment. Sometimes you'll see this oftentimes you'll see this written as the outstanding balance. So it's not outstanding that you have a balance, but it's the balance it's what you still owe that's out there. That's why it's called the outstanding balance, and sometimes they might even call this outstanding principal. So cap B sub K, I'm just going to say the word balance, but it's, again, sometimes called outstanding balance or outstanding principal, and it's immediately after the kth payment. So let's look at our timeline. This is our timeline for the loan. We have a loan amount, and then the first payment is always going to be one period after the loan amount, and then the next payment is denoted a cap R sub 2 and so forth. And then this cap B sub K will sometime between K 0 and N, we have some K value. We made a kth payment, and cap B sub K is going to be the balance just after that kth payment. That's actually what most of the problems, that's the first step in the problem in a lot of these is to determine what the balance is just immediately after you made a certain payment. A couple of cap B values that we know, of course, right after the last payment, we should be paying off the loan. It's the last payment, so we pay off the loan. So the cap B sub N value is going to be 0. Remember, N represented the number of payments. And of course, at time 0, the loan amount we can think of as a cap B sub 0 value. Let's go back to the picture for a K value between time 0 and time N. Cap B sub K, again, is the balance just after the payment. Oftentimes we'll be asked, what is the balance just before the payment? So I'm going to use the symbol. If we're looking for the balance just before the payment, I'll use a cap B sub K again because it is a time K value, but I'll put in a superscript, a BF, to represent we're looking at just before that kth payment. Now look, this is not hard to relate these symbols. Let's think about it. If we owe the bank $1,000 and we walk in and we make a payment of $100, then now we owe the bank $900. And so symbolically, if you look at the balance just before the payment, you subtract the payment amount, then you get the balance just after the payment. And rewriting this, solving for the balance before the payment, we get this equation, that the balance just before the payment is the balance just after the payment. You have to add back in the payment amount to get the balance before the payment. Okay, I want to look at one other way to talk about or to derive the balance just after, or actually another way to look at the balance just before the Kth payment. And I want to do that by backing up a step to the time period just before time K. In other words, at time K minus 1. At time K minus 1, I have a balance just after that payment. Now, if you owe the bank, so let's again go back to our example. Let's say that we just made a payment. We owe the bank $900 now. The question would be, well, how much would we owe the bank one period later before we made a payment? Well, we just need to accumulate the 900 one period then to get the amount that we owe just before the next payment. We accumulated, of course, it's unlikely that you're going to have a loan at 0%. That's why we need to accumulate that. So that symbolically would be saying that the balance just before the Kth payment is the balance immediately after the K minus first payments accumulated by multiplying by a 1 plus I. Okay, so we have these two different ways of calculating a balance, a balance immediately before the Kth payment. All right, so I will see you in the next video.